Hello friends, welcome you all in the video parts tree. So in this video we are going to discuss regarding what is parse tree, what are the steps construction of the parse tree, and what are different types of parsers. So basically parse tree is a graphical representation of symbols. Parse tree is basically it is a graphical representation of symbols. The symbols can be terminal or non-terminals. So parse tree is basically a graphical representation of symbols, and that symbols can be terminal or they can be non-terminal. In parsing, the string is derived using the start symbol. The root of the parse tree is the start symbol. So the root of the parse tree is the start symbol. So string is derived using the start symbol. So in parse tree, the string is derived using the start symbol. The root of the parse tree is that or is the start symbol. It is the graphical representation of symbols that can be terminal or non-terminal. So parse tree is basically a graphical representation of symbols, and that symbols can be terminal or non-terminal. The parse tree follows the precedence of operator. The deepest subtree traverses first, so the operator in the parent node has less precedence over the operator in the subtree. So parse tree basically follows the precedence of operator or operation. The deepest subtree traverses first, so the operator in the parent node has less precedence over the operator in the subtree. The parse tree follows these points. So in a parse tree, all leaf nodes have to be terminals. All interior nodes have to be non-terminal. In order traversal gives original input string. So these are the basic steps, basic points that has to be followed by every parse tree. First thing is that the leaf nodes have to be terminal. The interior nodes must be non-terminal, and in order traversal of that particular tree gives the original input string. So if you in order traverse that particular input string, that particular tree, so it will give the input string for us. So these are the points which will be followed by a particular parse tree. Now coming to the examples, the production rules are given like this: t equal to t plus t or t into t. So t, you can have the possible combination A or B or C, and the given input string it is given is A into B plus C. So first stage, from the given input symbol, given production rule is S can have the form S plus S. So now this S can again be replaced by S into S plus S. So now this S is replaced by the terminal symbol E, and then in the second stage it is replaced by the B, and in the third stage it is replaced by C. So the input possible symbol, like in this way, is A into B plus C, A into B plus C. So in this way, the A into B plus C, the input symbol, we are going to obtain. So in this way, the input string, and based on the input string, we are going to obtain the given parse tree for that particular input string. Now coming to the next terminology, that is called as ambiguity. Now what is ambiguity? A grammar is said to be ambiguous if there exists more than one leftmost derivation or more than one rightmost derivation. So a grammar is said to be ambiguous if there exists more than one leftmost derivation or more than one rightmost derivation or more than one parse tree for a given input string. So that particular grammar, it is called as ambiguous grammar. A grammar is said to be ambiguous if there exists more than one leftmost derivation or more than one rightmost derivation, and if there are more than one parse tree for a given input string, then grammar is said to be ambiguous grammar. So this type of grammar, it is called as ambiguous grammar. If grammar is not ambiguous, then it is called unambiguous grammar. So if the grammar is not ambiguous, then it may be unambiguous grammar. So ambiguous grammar is that if there exists more than one leftmost derivation or more than one rightmost derivation for a given input string, then that particular grammar is called as ambiguous grammar. For example, if the given input string is given like s equal to a s of b or ss, and s can have the input symbol epsilon also, and for the given input string a b, so the above grammar can generate the parse tree like this: s of a, so epsilon, and then a can is replaced by like this leftmost derivation. So we are going to replace this with the leftmost non-terminal first. So a and then b. So it is one possible parse tree, and second possible parse tree is that a s of b, and then so like this. So in this case, for this input string, there are two possible parse trees. Are possible. So this particular grammar, it is ambiguous grammar. So if the grammar has ambiguity, then it is not good for a compiler construction. No method can automatically detect and remove the ambiguity. You can remove the ambiguity by rewriting the whole grammar without ambiguity. So no method can automatically detect or remove the ambiguity, but we can remove the ambiguity by rewriting the whole grammar without ambiguity. So ambiguity is that more than one parse tree are possible for the given input string. So in this way, we have seen the example on the ambiguity. Now, what is parser? Coming to the next terminology, that is called as parser. Parser is a compiler that is used to break the data into smaller elements coming from lexical analysis phase. So parser is a compiler that is used to break the data into smaller elements coming from lexical analysis phase. So the parser is used to break the data into smaller elements which are output from the lexical analysis phase. Parser takes input from the sequence of tokens and produce output in the form of parse tree. So input to the parser is set of tokens and output from the parser is the parse tree. So basically this parsing or the parser can be classified into two types. One is called top-down parser and second one is called bottom-up parser. Top-down and bottom, these are the two types of the parser. So what is top-down parser? The top-down parser is known as recursive parser or predictive parser. Bottom-up parsing is used to construct a parse tree for an input string. In the top-down parser, the parsing starts from start symbol and transfer it to the input symbol. The top-down parsing is also known as recursive parsing or predictive parsing. So it starts from start symbol and transfer it into the input symbol. So the parse tree for the input symbol ACDD is as. then this T it is replaced by this RNF, and then if in this way ACDV. So this is the parse T for the input symbol ACD. Now what is bottom of parsing? Bottom of parsing is also known as shift reduce parser. It is used to construct the parse tree for an input string. The parsing starts with the input symbol and construct the parse tree up to the start symbol by tracing the rightmost derivation of the given string in reverse. So the production rules are given. E derives T derives T into F. T can take the T can be replaced by ID, F can be replaced by T, and F can be replaced by ID. So the given input is string ID into ID. So ID, so F can be replaced by ID. So like this. So the first step is ID into ID, and then we have replaced the ID like this. Now second step. So for this particular input symbol T, you can have the combination like T into F and ID, and then so in this way we are going to replace this input string to obtain the parse tree by using the bottom of parser. Now this bottom of parser is classified into various parsing, that is shift reduce parsing, operator precedence parsing, and table driven parsing. So in that we are having LR1 parser, SLR1 parser, CLR1 parser, and LALR parser. So this way the parsers are classified into different types. In the next video we'll discuss regarding all these types of parsers.